All right.
Hello, world.
All right, so let's get going. Maybe. Here we go. All right, so this is going to be Intro to Modular 2D Animation. My name is Tim, for anyone who doesn't know me. I'm a senior software developer for Disney Consumer Products here in Memphis. Today we're going to be taking a look at some of the higher level concepts of modular animation. We're going to be getting into a detailed look of some of the key features of a piece of software called Spine, which is made by Esoteric Software. And then depending on time, we're going to be walking through an example of how to rig and animate a basic model. So before we get too far into that, we're going to just take a very, very brief look at how a large majority of game developers, both big and small companies, still animate their 2D assets today. So good old sprite sheets, exactly. So we're going to start out with just a standard character. So this is Spine Boy. He is like kind of the official, unofficial mascot of Spine. A lot of the prepackaged demos that you can get include him and include a lot of different animations and things you can do with him. So in the old days, if you wanted to make a particular asset animated on the screen, what you would have to do is you would have to go to your art department and say, this character right here, I want him to do something like walk. And your art people would then go through and they would create 30 different images of him, drawing him over and over again in slightly different poses. Anyone that's ever used a little flip book as a kid or, got out of a Cracker Jack box, exact same concept. So the game engine would go in and basically would just render each one of these one at a time in sequence until you actually got a smooth, fluid animation. And all 30 of these images here, this produces about 1 second of animation. When you reach the end, you just loop it back over to the beginning, so long as your user's input designates that you should be doing that. So extremely cumbersome, and extremely resource intensive, not just from a development standpoint, but also from a game engine standpoint. Having this many images kept in memory simultaneously that chews through a lot of space. And as games have evolved recently to include higher and higher resolution graphics, the constraint on space is growing because you can't just go with the same old, 64 by 64 sprite images and expect your players to be engaged with that quality of artwork. So about 2 or 3 years ago, what wasn't really a new concept, but a couple developers came out and kind of took this and ran with it and said, well, what if we don't animate outside of the game? What if we actually animate in real time inside of the game? And then that's where they came out with the concept of modular animation. So we're going to take a look at modular animation real quick from a high level and try to answer some questions about what it is and what it isn't. So we're gonna bring Spine Boy back up for a second here. So normally we would just tell our art department to go in and say, give me this character. He looks like this. This is a standard pose for him. But since we're going to be taking a modular animation approach, what we're going to tell our art department to do instead this time is that we're going to break this character up into multiple pieces and multiple layers within a PSD, an Illustrator, whatever the art tool is being used. And then we're going to reassemble those pieces back in Spine. And when we do this, what that's going to allow for us to do is that's going to allow us to create a bone structure that we can then bind those images to. At this point, you're working in an animation environment that's similar to a lot of 3D animation. Anyone that's worked with 3D models or rigging 3D models would be familiar with bone hierarchy, posing, and some of the constraints within there. So why do we want to do this? This seems like a lot of extra work. I could just draw the same image over and over. I just call it by index and it does its thing. Why would I want to go to all this extra trouble to do this? So we're going to look at why we would choose modular animation over traditional animation techniques nowadays. First, Size is probably the biggest thing. The sprite sheet you saw earlier in the slide deck, each one of those images was about 48K. The resolution was 200 by 360. So by the time we got all of those massed in together, that one animation is going to be taking up 1.4 meg in memory. Doesn't sound like a lot, but when you start throwing dozens of animations or dozens of assets, now you're starting to talk about a game that is going to consume hundreds of megs of memory. And in a 2D environment, which primarily is targeting mobile devices these days, usually memory is a lot less than that. It's very constrained in order to get the game to run efficiently. So what you're looking at now, that exact same animation and this broken up into a modular format, the entire package to deploy to the game, including all of the sprites, the JSON file describing the animation, and the actual sprite atlas itself, is only about 92K total. So already we're looking at about a 16x size reduction just in that one asset and just for that one animation. Obviously, as your assets start increasing in size and complexity, those savings are going to be even more than that. We're going to actually take a look at it's a fairly complex rig later on, where you're going to see upwards of a 30x space savings. So art requirements, obviously, if I don't have to tell my art department to draw 30 images of the exact same thing, they could be drawing 30 different images. They could be spending more time making the existing image more detailed, higher resolution, or you don't have to pay for a full-time artist. You can simply bring in part-time work or not staff as largely for your art requirements. Animation smoothness is also really a really big factor here. We'll see more in the demos here shortly, but traditionally, if your game loop was running a little long and you didn't account for that properly, your animations would you would get a jitter effect. Your animations would hang, and you'd see what I like to call a stair step effect in your animations, where you literally can identify one frame between the next. And with Spine, you don't have to worry about this because the runtime is going to take care of mapping out your target vectors for any given bone and any given image, and it's going to create an interpolation curve, and that curve is going to allow you to basically call up with whatever the game time is in your loop, and it's going to tell you exactly where it should be. So if your game loop is running long, you're not going to see it instantly jump from one spot to the next. It will smoothly transition there. Another big advantage is animation mixing. That is something that you just cannot do with traditional animation techniques. You can't take one set of sprite sheets and intermingle them with another and expect that to resemble, anything that you're trying to go for. You can't take a running and a jumping at the same time, mash them together, and oh look, he's run jumping now. It's just going to look like he's having a seizure. With Spine, you can tell it, take this animation, and I want there to be a 13 frame overlap, and it's going to take all those steps, and it's going to figure out exactly where all those vectors need to be, and it's going to blend those animations together. So when you're doing things like aiming a weapon and jumping at the same time, it can handle that without any problem. We also have procedural animation, which is another big thing, and another thing that is not impossible, but it's very, very difficult to achieve through traditional animation methods. And by procedural animation, I mean you can set an invisible bone out in front of your model, and you can bind your weapon hand to that bone. And then throughout your game loop, you can take your user's input and reposition that bone to wherever wherever the player's aiming on the screen, and Spine is going to go in and it's going to make the model adjustments necessary to where that gun hand is going, or that weapon hand is going to be pointing towards whatever spot they're aiming at. We'll see a demo of that towards the end. Last but not least, asset development time. Obviously, if you're not having to go back and wait on an artist to make revisions to an entire series of sprites, and you can just, they can go in and tweak as needed. It cuts down the development time, I would say, at least 5-fold. It's probably more than that for people who are more experienced with this. I found that the turnaround time on assets is just, you can literally go through, rig, animate, and publish an asset in less than an hour once you become comfortable and familiar with the tool. So that's what we're going to talk about next. We're going to talk about Spine in and of itself. Again, like I said, it's produced by Esoteric Software. Originally started as a Kickstarter campaign back in January of 2013. It actually became really popular really fast. They met their 12K funding, I think it was like in 3-ish days. And then they went on to surpass that. I think they ended up somewhere around the 70,000 mark when it was all said and done. It is available on all major platforms, PC, Mac, Linux. So whatever your favorite flavor is, you can get this tool for it. The functionality of the tool is basically identical across all platforms, save for, small minor nuances that you'd be familiar with, for instance, positioning of menus, close buttons, things like that. It comes in 3 different tiers. You have a trial one, which is exactly what you think it is. It's a full featured trial. The only problem is you can't save with it. So you can spend hours and hours working on it, playing around with it, but at the end of the day, you can't export any of that out. You have a $70 essential pack, which is most features are unlocked. And then you have the Pro pack, which is close to $300, and that's all features unlocked. Now, the difference between the two, the big difference between the two, is with the Essentials pack, you don't get your IK, your inverse kinematics. There's also some tool features in there like onion skinning or ghosting in the animation editor that you won't get with the Essential pack. But for basic editing, and the Essentials will cover 90% of your needs. I didn't put it on here. There technically is one more license above that, and that is an enterprise license. Enterprise and Pro licenses are identical. The only thing is Pro has a revenue restriction. So if your income is greater than, I think it's like $500,000, you're required to bump up to the enterprise license.
At that point, they can have it.
Yeah, exactly.
How long is the trial? Or is it just you just can't save?
You just can't save. Okay. Yeah, the trial's open-ended.
Is this a subscription or just one-time purchase?
One-time purchase, and you get all future upgrades. So there are several other tools out there that perform similar functionality to Spine. The other biggest name one is called Spriter. If you wanted to take a look at that, that is actually available through the Humble Bundle right now. So about, I think it's like whatever it's up to right now, $12, $15-ish, somewhere in there.
Still, I think the Humble Bundle just ended.
Oh, did it? Oh, okay, gotcha. Well, you might not be able to. I know Spriter's cost is similar. Their Pro version, I think, is about $70. Similar in most functionality. One of the biggest things that I think that sets Spine apart from a lot of the others is their support for runtimes. When you go with Spriter gives you a very generic runtime, and you're left to kind of adapt that to whatever engine you're using to handle all of the other gaming needs. But with Spine, they officially support all of these. So Cocos, Unity, XNA, they've got ActionScript, Monogame, XNA. It's huge with the number of runtimes they've been able to support, and this was supported out of the box. Since then, there have been a couple large name and even some small name gaming engines that are up and coming that have gone in and created their own adapted version of the runtime. And even on top of that, all of the runtimes are completely open source. You can go in, modify them however you choose to. You just get out on Git and pull it down. They've also published, I believe, it's five or six generic runtimes covering most of your high-level languages. So C++, C, C#, JavaScript, Lua, ActionScript. So you can pull these generic runtimes in, and at which point, and that's what a lot of these community runtimes are. They just pull down the generic ones, and they created wrappers within their own namespace. One of the demos we'll get to later, we'll look at Wave Engine's implementation of this and how easy they've actually made it to implement these characters. So some of the highlights, kind of some of the stuff, same stuff I talked about earlier. But things to really kind of focus and dive down on is mesh distortion, and not having to recreate your sprites with, you know, different impact effects or distortion effects due to their animation. Once we open up Spine, we take a look, you'll be able to see how you're able to actually map a genuine like vertices mesh onto a texture, and the weight of the bone structure that is bound to that mesh will cause those distortions for you. Interpolation curve editing. So if you want to do ease in, ease out functions on your animations. Standard dope sheet animation editor. Anybody that's worked in any kind of animating software will immediately be familiar with the style. It's very keyframe driven, and then allowing the interpolation engine to come in behind it and kind of fill in the rest of the gaps.
What's called dope sheet?
I'm not sure why it's called a dope sheet.
I think it's an old school cell animation term.
I feel like that's. I feel like I've heard that before. Like they used to have to dope cells, and that was what, like coloring it in or something. Or
So.
yeah.
That's exactly what it is.
Yeah. Skins is another really cool feature that Spine has. And what this allows you to do is, for example, if you had, let's say you had a dozen NPC enemies, and they all shared the same skeletal structure, but they, you know, they look slightly different. They might be a different class of one another. What Skins allows you to do is to basically have multiple image base set directories, and to take all of those base images and map them uniformly. So all of the same animations, poses, weapon sets can be applied instantly to all of these other variations. We're going to look at an example of that here shortly as well. And then, of course, inverse kinematics, being able to set you know, targets and goals for a particular bone structure. It really, I can't express enough. This is actually, me personally, this right here was the deciding factor as to why I went ahead and shelled out $300 for the pro version, because animating without it just takes too long. And I mean, there's really no other way to say it other than it takes too long. This will save you a tremendous amount of time, and even something as simple as a character walking, being able to set those target points to where the feet land, and being able to use those target points to modify the bone structure. You'll see here shortly. So that being said, that's the slide deck. Nothing too painful, but we're going to get in real quick, and we're going to pull up about 3 or 4 different examples that come packaged with Spine. Again, depending on time, we're going to look at a very small finished product using Spine. I will show you one of my personal Spine implementations using a third-party runtime. So that being said, let's go ahead and start by, let's see here, desktop. There we go. Hero. Oh. All right. So what you're looking at here, this is the, there we go. This is the main window in Spine. This is where you go to set up poses, and you actually create your models. This is a simple hero model that comes packaged with Spine. And let's start by looking, let's start by turning off some of this stuff. So the first thing you're going to want to do in Spine is you're actually going to want to point it to your images directory. And it's exactly that. If you look at this images directory, you're going to see it. Okay, let me grab that. It opened on that one. Put that over here. There we go. So this is the character broken down into its individual components. Nothing crazy special about these. All of these are just transparent background PNG files. One of the other nice things about Spine is they do also provide you with a series of scripts that will allow you to automate the export and positioning of all of these assets through most major image editing software. So Photoshop, Illustrator, GIMP. They've got custom scripts that will go in, and as the character sits in your editor, it will literally export it and build out a JSON file with all the positioning information. So you could just open up Spine and import it in, and then
each one of these would be a different layer.
Yes, each one of them would be a different layer. And depending on what tool you're using, they either have to be nested under a master layer, or they have to be at the topmost layer. The scripts can get a little finicky sometimes. I had to play around with Illustrator for a while to actually get a feel for it. So, all right. Nope, not what I wanted. There we go. All right. All right, let's come back over. All right, so like I was saying, once we get the character position and everything, we come in and we'll define a bone structure. And I'm just going to go ahead and look at that. Let's see here. What can we start with? Let's start out first by looking at some of these meshes. I know that was one of the big things I mentioned earlier. And we'll come down here and click Edit. So what this is essentially allowing me to do is go in and define a simple triangle mesh for every point in this mask. One of the beautiful things about the Spine runtime is once you've defined your mesh, if it's not in the mesh, it's immediately cold. Never stored in memory, never even called up. It just doesn't even know it's there. So this is one way to get a huge performance benefit out of this, because even though this is all transparent backing, it still takes memory to hold those bits in place. With this, what this is basically going to do is when the image is loaded up, it is loaded up by its mesh and held in memory by its mesh. And it chops all this up and sorts it out of memory and then reassembles it in real time. It is also worth noting that, of course, with any savings, there is going to be a trade-off. And one trade-off with Spine is yes, these are more CPU intensive, not so much so that it's going to impact gameplay. When we look at the finished demo, at one point, depending on how far we get into it, at one point, I mean, we're talking 200 or 300 assets being rendered on the screen simultaneously. All the animation's fluid. But yes, if you went bit for bit and did a performance chart, between traditional sprite sheets versus this is going to be more CPU intensive. So let's see here. Now that we've seen meshes, come back over here for just a split second. There we go. All right. We're going to jump out of this. We're actually going to hop into the animation. Well, so we're going to grab this bone real quick just so you can get a feel for what the posing looks like. I wish I'd have colored these bones before I came here, but you can see each one of these sections is bound by one of these bones. And over here in the hierarchy, you can actually see how they all flow together and what their relationship is to each other. So if I come in here and I move this hip bone, oh, hey, I forgot this had IK on it. So actually move them like that. So there you go. So this is actually a really good example too. These little red dots you see down here, these are IK targets. This is basically telling it to try to drive this bone to this target as much as it can. And if that means distorting any of its parent bones along the way, it will do that as well. So what that actually means is you could actually come over here and take this hip bone, and you could drag him all the way up, and you see how they're always going to try to bend themselves back towards that target. Or if they're on the ground, I mean, you could just imagine how much effort it would take if you had to go from here, there we go, from here to here in one pose. I mean, that right there was probably about 30 different bone movements, give or take. So IK kicking in really helps you just kind of alleviate a lot of that necessity. So let's hop in here. We're going to take it out of set mode. We're going to go into animation. Yeah, there's a lot here. And actually, it did not retain my previous layout. So there we go. Let me condense some of that down. We'll be coming here. I'm going to turn off the ghosting effect. Good. No weights. And we're going to turn off bones. All right. So this is the main dope sheet. And again, anyone who's used any kind of animation software would be familiar with this concept. What you're looking here is number of frames, and the time in which those frames are implemented is completely relative and configurable. This can be 30 frames per second. It can be 30 frames per 2 seconds. Every one of these indicators denotes a keyframe for that given object for that given property underneath a given object. You can go in, edit them manually. You can move them around, push them back and forth, whatever you need to. There is an auto key feature, meaning that if I came over here, let's see here, let's see if we can do one of these real quick. Everyone likes an animation called test. So with the auto key feature, I think my battery's starting to go there. We go. I think my battery's there. So you could literally come in here, raise this up, and you see as I move that forearm, it was immediately keyed. Maybe. I don't know. I haven't swapped batteries in this thing in a while, so that seems to be acting better. Yeah, we'll see. That might work. So you can see as I move that, it automatically created a keyframe for me. If I go in and I advance that to, let's say, 5 frames up, and I bring that back down, you'll see now that another keyframe's been implemented, and that those two are now connected. So if I go through here and I hit play, he's just going to shake his sword up and down. If I bob his head from side to side, whoop, I didn't grab all that there. There we go. Oh, I'm not grabbing bones. There we go. Still not what I'm going for here. Yeah, that's the head bone. Eyes. Yep. There we go. Yep. So now we can also bring that in a little bit. Bring that in there. We can walk that back over there. So now he's just head banging and throwing the sword around. He's thrashing. There we go. All right. So that's a really crappy animation. Let me show you what a finished animation is supposed to look like here. We'll start with just simple run. And we'll hide the bones again. There we go. Perfect. Let's see here. Bring it 1x and run. There we go. Now you'll immediately notice some things that you don't normally see in traditional 2D animation. You'll see the hair swaying. Not a big deal. It's not hard to make another frame where his hair's slightly off. But one thing to note while you're looking at this is to watch the mesh. Actually, let me slow this down a little bit. There we go. So you can actually see how the mesh is distorting these individual images, and how it's making them curve to get this bouncing effect. And this is literally just, let's see here. Looking at the mesh for the head, it looks like all in all for 1 second we have 5 primary keyframes and 1 wrapping keyframe. So in 5 in 5 keyframes, we were able to go in and make his hair sway while he's running, to give the effect that he actually, gravity's kicking in, he actually is running. Now, that's cool. Let me show you something cooler. Mesh distortion can also be used to give you an effect of something that's not actually there. We're going to switch over to this animation. Now again, we're going to click on that, and we're going to watch as this mesh will distort the head. And again, let me kick it down to 0.25 seconds. All right.
Ooh.
Exactly. So there's no 3D techniques being used here. The only thing that's being done, let me break this down because we can actually step this up to the frame by frame, is it will start by distorting the head and pulling these features around. If you stop it, you look at it, you can see the distortion because that eye is not really meant to be stretched to that position. As the head's turning, we hit this keyframe right here, and that's a flip X keyframe. So now you'll see the distortion immediately jumped to the other side. Now, if you're running at 30, 60 frames a second, you can't see this. Your eye literally cannot catch this. But now that we have inverted the head, we can continue to allow the mesh to kind of relax and undistort it back into its original position. The head stays that way for a little bit and then begins turning back the other way. And just the opposite happens. It turns back around. You get the distortion on the left side. The flip X engages. Now the distortion's on the right side. And then it continues to wrap around. This is all being done with just simple 2D images. There's nothing extra here other than your typical 2/3 front profile view. And just to see it at a full 1x how it's supposed to be running, you'd think that you're looking at a 3D model.
That's impressive.
Yeah. So that's an example of how mesh distortion can be used to add to the effect and add to the depth of the character. Let me see, was there anything else that I wanted to cover here? We can look at interpolation curves real quick. We'll probably touch base on some of that here in a second with one of these other models. Actually, let me jump back to the running because that was something that I didn't cover. So we're at 1x right now, 1x speed. And this is about what you would expect quality from either traditional or modular animation. It looks solid, it's nice, it's fluid. When you start slowing down this animation, that's where spine really, really begins to shine. So if we're going to go at 1/4 speed, right? Now, if this were a sprite sheet, this is what it would look like. Very easy to pick out those individual frames. It's very jittery, and you can see very hard changes between the frames. If you slow it down to 1/10 X, you can see it even more. So what Spine's runtimes will actually do is, like I mentioned earlier, you send it what your loop time is, and it will interpolate where these positions are actually supposed to be at that given time. So I come over here and I turn on interpolation. That's what Spine's engine is doing now. And it allows you to literally slow it down to a snail's crawl without losing any quality or resolution. I could take this down. I think it'll let me. I could take it all the way down to 1% of its original speed, and you get no loss in quality, no loss in transition, no jittering effects. It continues to be a smooth animation, albeit a very, very slow one. And the same holds true. If you run 2x, you get no frame dropping. It's just moving these a lot faster.
You turn off the interpolate with the 2x?
Mm-hmm. Can't tell the difference. If I shifted let me see here. Could I actually get it to do that? Stepped is always fun because stepped is actually just showing you the keyframes and nothing else in between them. I think I would need to. I think I actually need to go into the setup and actually jack around with some of the core settings of what it's interpreting the time to be. Because right now it is. I think right now I've got it capped at 29 frames per second, 30, somewhere in there.
Now, could Spine output to a traditional sprite sheet?
Yep, it can output to a traditional sprite sheet. That's actually in the presentation. Let's see here. Pull it back up. Here, that's actually how I made that. I told it to output it. It has several different output options. Let's see here, export features. So you can output just the data, the underlying data. You can output a GIF or GIF, depending on whatever skill you're trying. You can output. You can actually take it out to a raster format, either a single frame or sequence. And again, you could choose whether or not you just want the current animation or all skins, so on and so forth. Or you could output it to a video file. I've actually seen videos of some of the more advanced users that go in and literally create entire scenes in Spine. All assets, environment, NPCs, everything they build out in Spine as a passive environment. And then they just go in and they just export the whole thing. And then when they go run it, when they go to pull it into their game engine, it's literally like 2 lines of code and they get a scene, an entire functional animated scene.
I could see like a background you want to output as a API and kind of loop in the background.
So yeah, lots of different. Typically, what I'll do is I'll come in here. I'll go PNG. And I'm sorry, no, data, there we go. And this will actually, this will create your atlas. It will take care of your texture packing. One cool thing they actually added, it was probably about 6 months ago, is that they will go in and, you configure it just about however you want. But one of the problems they were having earlier is, and those that work in 2D texture will be kind of familiar with this, when you're working in OpenGL, your textures are required, your resolution is required to be a power of 2. And they've actually got this fixed now to where you can actually come in and check that power of 2. And I just leave it on by default because why not? But it will take care of any resizing or reordering to make sure that your that particular section of the atlas will pull out in the correct size. They had a lot of issues a while back with that, and you would run your application within a Windows framework. Assets look great. Pull it into something like Android, and everything just goes to shit. And then, like I said, there's a lot of adjustable options about the different padding, scales, and all that. Most of this I've just left alone by default because it works. So why break it? But so let's see. That's a high level. Let's go ahead and look at another example real quick. Let me pull this back here to get to. There we go. All right. So now what we're going to look at skins and attachments. Oh, there we go. So let me back up here. Let's go back up to and we're going to open up goblins. Everyone likes goblins, right? Oh, yep. There we go. Well, here, there we go. All right. Perfect. So what we've got here is just a basic NPC enemy. And he comes prepackaged with one animation, just a walking animation, nothing special. Now, if we want to go in and we want to add a variation of this character, and when I say variation, I mean like complete change, not just like a shade change or something like that. Though it is worth mentioning that is something that Spine can do. Assuming I can get it to come up here. Oh, I'm in animate, so I can't do that here. You could actually go in and tell it to retint, and it will actually handle that as part of the runtime engine as well. So any of your your object or artifact effects or damage impact or anything like that can actually be set up as part of an animation. You can actually have them pulse a certain color, or something like that. So let me put that back here. There we go. So if I wanted to create a new character out of this, but I didn't want to go through the hassle of recreating this animation, what we can actually come in here is define a skin. So when you define a new skin, you're going to give it a name, and it's going to create a directory within your project's working directory. At that point, so long as the name of your images, you'll also see them here. So long as the name of your images are uniform between your two, so for example, head, so I can get to come up there, head, it's going to take those, even if they're different size images, it will take those and it will position them wherever head is located in the bone structure. And you can go in and you can actually make small adjustments for offsets if something about a particular skin, the head's a different shape and needs to be offset on the x-axis a little bit or something like that. But what this allows you to do is in this one texture, in this one spine project, is now you can have theoretically an infinite number of different skins. And during your runtime, all you have to do is you instantiate this one object and then you tell it what skin to use. So if you have a kill and fade mechanism in your game as you're playing, as soon as your NPC fades out, you can then pull that back into like an available assets queue. You can pull it out of the available assets queue and re-render it under a different skin without going through the process of reinstantiating the object from scratch. Within Spine, you can actually flip back and forth between these skins just by clicking on it. And you'll see that the animation between it doesn't change at all. I mean, they are identical.
Looks like they forgot the toes on that one.
Looks like it, yeah.
So do mesh transformations carry in between the two? Like I noticed on the male goblin form, it was deforming the mesh on the ears they bought. But
they do not. No, you would have to go in. So like here, let's drag that back here. Let's find head. That's probably the easiest one to. So neck, head. So what you're looking at here, right here, this little puzzle piece is an attachment slot. There we go. And then there's the head. So let's come in here and look at it. Maybe. There. Actually, to be honest, this one doesn't even have a mesh defined for it. If it did, let me see if I can get it to, nah, that's going to take way too long to try to do that. If it did, no, your mesh is defined per image. So you'll notice under head right now, it says Goblin Girl /head. That's because I've told it to use the Goblin Girl skin. If I come back down and I switch over to Goblin and come back up, you'll notice that now it says Goblin /head. It actually looks like this one does have a mesh defined. Yeah. So this particular one, yes, the mesh would distort. The Goblin Girl would not. And that was actually that was a good call. I've never actually noticed that when looking through these, but I would almost be willing to bet that if we went down to foot, yep, sure enough. Well,
the girl, the ears, and the ponytail would have to be separate objects. They can't
they just basically didn't split it, so they just left it in there as one piece.
They did. Now, the things like hair and ponytails don't necessarily have to be a separate object. You can actually create a separate bone structure, and you can bind that bone structure to only that portion of the mesh. And then once you do that, it will actually flow and distort independently of the head itself.
I think it's because it's an overlap.
Oh, probably, yeah.
You know what I'm saying?
I really think this particular example was probably hastily put together. Because, yeah, flipping between the two, Goblin has mesh, Goblin Girl has nothing.
No, I mean, it's still awesome. It's actually good to recognize these kind of things and see, like, you know, the kind of things that have to go into it. Like right there, that ear, the way it is right now, you can't distort that, right? Because everything in the background would be stretched.
It would distort the bottom part
Yes.
of the ponytail.
Right.
Yep.
And that's why the ears don't bob, is because whoever made that didn't draw the ears as a separate object.
Correct. Yes. Yeah, I see what you're saying now. Along with the slots for skinning, you can also create attachment slots. And these can also be switched out in real time. So let's go back to our animation. So we see now she's carrying a spear. If we want to, we can flip to our goblin friend who is also carrying a spear, but I can just as easily go up to his left-hand item slot and I can activate a dagger instead.
Did it only do it for one keyframe? Is that why that's happening, or what?
Yeah, I have auto key still turned on, and I didn't realize that. Yeah, that's actually exactly what's happening. This attached left-hand item, it sees a keyframe there now. Actually, if I back that all the way up there, yeah, now it would be. So again, just another method that Spine just makes it that much easier. You don't have to actually go in and have 30 variations of the same sprite, not to mention 30 variations of their animations. You have an attachment slot and you can simply insert a new weapon. You can also, during your animation process, tell it to swap out entire body parts. So if, or with the attachment for a given item, if he had an item that required an open hand use, you could tell it to not only swap out the attachment or swap out the item, but swap out its hand for one hand image.
Right.
And then that one hand image can actually be bound to the exact same bone and function the exact same way.
Yeah, like you have like a bow and arrow.
Yeah, exactly.
Opening his hand.
Exactly. Yeah, you have where he's exactly. Yep.
You know what this whole style of animation reminds me of that game Dragon's Crown for PS3. Did you guys see that?
Mm-hmm.
Yep.
It's like they animated
That's been a
it the
few
exact
years.
same way.
That's been a, yeah, I remember that.
Have there been terms coined in the industry yet for when you have this style versus like? Because some people, I mean, there's still a huge push for pixel art games where you have to use the traditional style, whereas this, like, because this is really good. Like, sometimes you can see the objects too much and it kind of doesn't, you know what I mean? Like,
Sure.
on kind of like older Flash games, especially, it was like kind of crappy looking. But, I mean, do we have like a standard term for those two styles?
I think it's like for this like bone structure stuff. I think it's just 2D skeletal animation.
2D scale.
Yeah,
Yeah.
I've also heard it called like puppet animation.
Okay, yeah. That makes sense.
There's a couple of Unity assets that does this as well.
Style called hand painted.
Yeah. Painted or just traditional. Like this is
legacy animation.
In terms of like the puppet or skeletal style, this is definitely the best I've ever seen. Usually, I'm not a fan of it because I feel like it looks too like cookie cutter almost. Like that you can see all the pieces.
I mean, it literally looks like a puppet. It looks like you've got something on a marionette string, and it's just kind of like very jagged in its movements.
Right. But this actually, everything it can definitely. It seems like it can be pretty seamless.
So we're going to look at one more example here.
For sure.
And if anyone's crunched for time or needs to get out of here, or we just need to wrap up, just let me know. I can condense this. So this is one of the more complex examples that it comes with.
I've seen this on a gift somewhere.
As you can see, it's got quite a few art assets. I'm going to start by actually running the animation, and then we're actually going to get up into the setup and pose. just so you can get a feel for it. And actually, you know what? We're going to close you out, and we're going to close you out, and we're going to shrink you down, because I really don't, I feel like I really need to kind of get this as large as possible just to do a little bit of justice here. There we go. Again, you'll notice that all these graphics are high definition by standard. The torso of the Raptor itself, I believe, is somewhere around 1200 by 500-ish. Yeah, 1219 by 570. So this is the one I was talking about earlier when I mentioned the size difference, the size savings you'll get. So the when I start the walking animation, I went ahead and just did a test export of what it would take to get a sprite sheet for it. And for this one model with the rider, you're looking at about 23 meg. 23 meg for one image, for one sprite sheet, for one animation. Using Spine and divvying these up and rendering this in real time, it drops it down to about 785K. Now, of that 785K, about 720 of that is the art itself. Only about 60 of that is the actual animation data and the Atlas data. So even if you went, you could literally go in and add probably about 50 more animations, and you would not even increase the size to 1 meg. Let's come back over here. So we're going to start. This is literally, this is like their crown jewel when it comes to demoing Spine. Any of the promo videos you see that you know glorifying Spine, they'll be showing this, because the amount of work that they put into this one model is just, it's insane. And I'm going to go ahead and slow it down, because there we go. So this is basically making use of just about every feature in Spine that they have. There's skinning going on. There's IK involved. You'll notice, and we'll look at this in detail here in a second, you'll notice right here where his hands are, you'll see movement with the arms. You'll see the rider bouncing up and down. You'll notice his hands don't move. That's due to an IK target right there where he's grabbing onto the horns. So no matter how much your animation like bucks the rider, his hands are going to stay firmly grasped to that horn. Same thing with his feet in the stirrup. His feet are always going to be planted in that stirrup. So I'm gonna actually slow this down a lot more, just so we can really see some of the detail they've put into mesh distortion.
Is the whole character's body also an IK target, or is he drawn onto the saddle?
No, he actually is. Oh yeah, I should have pointed that out too. So within, where's he at? Here, let's just do this. I'll click to him faster here. There we go. So it's basic. There we go. Spine Boy hit. That's the start of him. So it's basically, you have your base asset, which is the Raptor, and then within the bone structure of the Raptor, we've created an entirely separate entity, which is the Spine Boy. And this is actually this character is referred to as Super Spine Boy. Small variation on the original one that they've iterated over time. So he is. You could actually come in here. I could click. Oh, I can't do that while he's. I auto key that. You can actually come in here and turn off. Well, I say that. Spine Boy torso. Yeah, I basically have to go in and click all of these. I thought I could actually do that from a higher level, but it looks like it's not letting me. Hold on a second here. Well, that's close, but you get the idea. So yeah, you could actually pull him out of there. It's something that I've never actually tried doing, but since you can do procedural animations, I can't think of any reason why you couldn't actually have a completely separate asset and bind the IK target of one asset to a bone on the other at runtime. I can't come up with a reason why you couldn't do that. I've never personally seen an example. I could actually do some research and and see if that's ever been done.
You can do it in 3D animation.
Oh, sure. Oh, yeah. I mean, if you jump on a vehicle or you jump on an animal or something like that, which that's, very similar to what this would be here. So we'll look at stuff like the tail. You can see the mesh that they've defined for the tail. The one thing I always like about this example is you can always go in and look at this raptor body, and you see this is one piece. There's not a whole bunch of segments making up his body. From his head to his tail, it's just one solid texture. But out of that, and you can actually already kind of see some of that just based on where it's at in the animation. We turn on the bones so you can see how they're moving. So the mesh is distorting in response to this bone movement, and you can see how it's giving it a perfect waving effect without the need for any additional assets to be brought in or modify that. You can also see that here in the leg. And the leg, I know actually they spent a lot of time building these custom meshes around it. You've got your basic outline mesh, which outline meshes will get the job done 98% of the time. If you really, really want to hone in, you can put meshes close to joint, to where joints would normally be, and that will really that will ensure that you retain as much detail as possible as the image is distorting. Let me jump back into post for just a second here. So again, like I said, with we have several different IK targets here. You got some right here where his hands are. And I'm just going to grab his hip bone real quick. So, there we go. Yep. There we go. So with those IK targets kicking in, you can move him around in the seat, and you don't have to worry about the positioning anywhere else. It's just going to automatically compensate. The rest of the bone structure is going to compensate for where he is at. If you pull him completely off, again, it's going to constantly keep trying to push him towards those targets. And that would be a great example is if you had a gun in this hand, your IK target could actually be positioned out here. And at runtime, you would bind to this, whatever this bone name is, let's see, front arm goal. You would bind that to your user input or set its position based on user input. And that would allow him to reposition his arm and target in real time. Same thing holds true for the raptor himself. We have IK targets for his feet. Allows us to have very fluid motion with. There we go. We can make him take a step, and you can see all the tendons bending, the thighs flexing, and things like that. Again, traditional animation. This just going from here to here. That's several hours work. I mean, that takes a considerable amount of time to generate that fluidity of motion. And in spine, it's literally just relegated down to, I'm going to pick this point up and I'm going to set it over here. And if I want to get really fancy, I'll put something in between just so that it arcs properly. Or you could reposition him as a whole. And again, those targets are constantly pulling those child bones down and trying to get them to stay in that one spot. So if you had him leaping forward or leaning backwards or rotating him. Let's see here. That wasn't the one I wanted to grab. I wanted to grab that. There we go. One other really cool thing to point out, maybe the tail end of this is, if you look at this raptor jaw and then you look at this raptor jaw is a completely separate image. It's unrelated to the actual body itself. But what we've done with this, you'll notice when I click on the body that this jawbone changed color. That's because this jawbone actually has been bound to the body, even though it's part of a different segment of the hierarchy. What this will allow you to do is, as the jaw image is bound to the jawbone, when the jawbone moves, the jaw image is going to move. But because we also have it bound to the body image, when the jaw moves, it's also going to distort the body image. So you can see that, you can actually see it flexing in his throat, flexing in the back of his mouth. So just another example of how you can get different body parts to impact one another. So let me jump back over here for just a second. I'm going to show y'all real quick a finished product, and then we'll take a quick poll, see if we're still good on time, and then we can walk through building one up from scratch. I've got a couple small models. I'll just pick one of them, and we can just throw stuff out there and take y'all through the process of what a simple animation would look like. Let me see here. I'm assuming I've got Java installed. I haven't actually tested this part. Shame on me. There we go. Super Spine Boy. Hey, I do. Sweet. So the guys that created Spine obviously wanted to showcase a lot of this. So they put this together. Super Spine Boy. It's just a running shooter. Nothing too crazy. But you get to see a very good example of what Spine looks like in a game during runtime. Again. Well. So you'll notice, again, binding that IK target to my mouse input allows him to track my mouse in real time. You'll notice that while he's doing that, it's also mixing this animation with his idle pose. It also mixes it with jumping animations, running animations.
Is his head being bound to that target there?
It is. Mm-hmm. Yep. And there actually is a now this part. This is just one part of it is done in code where it has a threshold. Once it reaches that point, it'll invert your x-axis, flip the image around so they can start aiming on the other side. If I had any one feature request for Spine, I would ask that they allow an angle binding limit for bones. I've actually come across a couple occasions where I was using IK on a biped figure, and my IK target got shifted just a little bit too far over to the right, and next thing you know, his knee was inverted and going out the other way. So that's just one of those unfortunate things, and yeah, hopefully they'll get to it one day. But again, and you know, I don't know if it's the projector, I don't know if it's Hangouts. It's normally not this jittery. I know that doesn't really sound well, but when you're demoing a system like this and you're looking for stuff like smoothness, let's see if I can get over here where we can actually get a couple hundred of these guys going. This isn't an impossible game, but it's pretty close to an impossible game.
Can you die?
Oh, yeah. Yeah, there's a little... Really? Yeah, it's way up here in the upper right. Yeah, I'm about halfway gone. All right, that's enough on that. You can go down here and you can see that. Well, if I can get that. But you see, I mean, there's a few dozen of these guys like running around here. All of them animated, all of them being controlled independently. And I lost. Oh, there you see slow motion kicking in, dying pose, reaches out for one last, and then he just dies. Yeah. So that's that's what Spine can look like if done correctly. I've also seen several implementations that were less than stellar. Didn't really do the software justice, but. So let's see here. What time has anyone got? Are we good on time? Is anyone 5:47? Does anyone need to get out of here, or we've been running for about an hour now? We're good. Okay. So let's go through real quick and let me back up here. Let's back up. Let's go to Spine. Let's go in here. Let's start a new project. New project created. Sweet. So the first thing we're going to do is we're going to create a model, and then, well, first thing we're going to do is import all the images. This is a relatively simple model. It shouldn't take very long to get it set up. Let's go browse. Let's go assets. Let's go Panda. Select that folder. Perfect. Cool. I don't even know if I'm going to do all these. We'll see. We might just do. We might do a Panda Lite version or paraplegic Panda. We'll see.
What's that framing up there at the top? Is this safe for work and children?
What's that? What?
I think that's a mouth. Let's see here. Right eye. So all I'm doing right now is obviously I didn't take the high road and just punch out a copy that was already staged.
Did that girl draw this?
No, this is actually my unhandy work.
Oh, okay.
Yeah, no,
Did you
this
make it in Photoshop?
I don't remember. I think I did this in Illustrator.
Okay.
Yeah, there's nothing pretty about this panda. When it's all said and done, you're gonna look at this and like, man, that's kind of jacked up.
Should be some other colors.
Let's see here. All right, so let's.
Yeah. Someone does this one episode where he goes, "What? He's good up here," and he just takes them off and off camera, puts his name down. It was a piece soon. Yeah, the animators having fun. That's why as soon as I saw the notes,
let's see here, lefty. There we go. Okay, and then right arm, left arm, right leg up, right leg up. Once I get the draw order sorted out, it'll probably look a lot better. I'll leave that over there so you can see that. Put that there. Got our right eye there. I feel like this head got rotated at a weird angle. Oh yeah, looky there. Yeah, that makes all the difference in the world. Okay, so right pupil, left pupil. And now he actually kind of vaguely resembles a panda. Albeit a very primitive one. So we would come in here. And this is what I was saying. I cannot place a value on those scripts that this thing comes packaged with, because when you're in Photoshop and you can literally just go click, run script, and you punch this out and bring it into Spine, and it's already assembled for you, it saves an immeasurable amount of time, especially when working with something that's more complex than, a couple joints and segments. First thing we need to do is take all of the right, move it up, and take the head and move it above torso. We need to take all of the left head. Oh, no. Ear, eye, pupil reflection. We need to move that up. Go in and grab nose, mouth. We need to drop. Whoop. Too far. Ear down. And now we should be able to come in and reposition some of these so that foot. Okay.
Apparently I can't tell my left from my right. There we go. Left foot, right foot. Nearly there, or nearly close enough to where I feel like we could probably animate him really quickly. There we go. All right, hey, we have a panda. So once we've gone in and created this panda, you'll notice over here, basically all these different attachments for the images are sitting underneath this root bone. I didn't realize how far off a root bone it was, so let's just move him back up and we'll center him here. So the first thing they generally recommend you do is you start out by selecting your root bone and then going and creating a hip bone. That just serves as a center point of gravity. It makes it easier for you to grab him, and you don't have everything bound to that root bone. That becomes important later if you're doing animations that will take you far off of one side or the other. You can actually just start immediately creating a bone structure off the root bone. It doesn't hurt anything. But just from a layout perspective, it's generally easier just to go find some central point in the model and work outward from there. Especially if they have multiple appendages or complex bone structure. So from here, they actually make it pretty easy to go in and create this structure. So from the hip bone, we're going to come down and we're going to, whoop, I'm not going to do that. We're going to make it so we can't select the images. There we go. So we're going to come in and we're going to bone, select the parent bone. There. Bone, bone, bone. All right, we're going to come back and select that one again. And with each one of these that I'm creating, it's automatically, you'll see that little red arrow, it automatically assigns whatever the previous bone you drew was as the parent of the next. So we're going to create a torso bone, create a head bone, and we're going to click torso bone, we're going to create an arm, and torso bone, and arm. Perfect. So let me come over here. We're going to collapse all those guys down. There we go. They also recommend that as you go through and create these bones, it's generally good practice to go ahead and name them as you create them. When you start getting over about 15 or so, it's too much to keep up with. I'm actually working with a model right now on a project that has it's one single texture, and that one single texture I think is up to like 37 or 38 bones. It's a segmented, almost like a segmented worm style thing. You can't keep up with it at that point anymore. It's ridiculous. So we have our bone structure, and we have all of our parts, and now what we have to do is we have to go in and basically say, I want this. Let's see, head, mouth, nose, ears, eyes. What am I missing here? Pupil, reflection, claws, arms, torso. So what bone was that? Bone 10. Put all that under bone 10. So now everything in bone 10 is bound to that. If we come in here to rotate, all right, good. Now we've got a working head. Let's see here. Bone 9 is torso. 11 is upper. 12 is lower. Right arm. 11. Right paw. 12. Almost there. 6, 7, and 8. And 8. And then 3, 4, 5. 3, 4, 5. And there we have it. So now we actually have a rigged character. And we can go in and pose him however we like. I'm going to go in here and I'm going to, let's just do it this way. Everyone likes exaggerated heads.
Next Disney mascot.
Yeah. All right, so let's turn off a bunch. Excellent. Perfect. So that's it. Now we are ready to animate it. Oh, I can actually show y'all something I forgot to cover in one of the examples earlier. Events. Events are a beautiful thing. Events will actually, they are exactly what they sound like. You can define certain keyframes that will actually raise an event in the runtime. And you can bind to those events being fired and trigger. I'll show you in the runtime. I have one where this panda has a footstep. You know what? It might not be a bad idea. Let's save here first. We'll go. Let's see. That's it. So this is one that was actually done up earlier, and I can actually show you this run animation real quick. So animated just like all the others, nothing crazy here, just a bunch of keyframes. But the one thing to point out is whenever his foot touches the ground, you'll see a little thing flash above him. Let's speed that up a
So
little.
you can trigger like sound effects.
Yep.
Okay.
You can bind it for sound effects. You can do stuff like you can actually bind it to where when that event is raised, you run your collision checks, so that if they're in the process of swinging a melee weapon, when they are at the peak of that swing, you can fire an event, or you can fire an event at certain increments of the swing.
That's cool.
Or if they were using like a chained melee weapon, you can basically tell it, fire the animation off, but don't actually do your collision checks until the ball end of that melee weapon has reached a certain point. And then from going forward off of that. So extremely useful. Yes, in the code example that we're fixing to take a look at, it is bound to the sound manager. I have a singleton sound manager running in the background, and every time it sees a footstep, you'll hear a footfall sound effect play.
You know what that reminds me of is that X-Anima game I was talking to you on Steam about?
Oh yeah, I've been playing. I hadn't.
It's just like that, but completely physics based. Or if like you hit him with the haft, like you're too close, it does no damage.
Yeah.
You gotta get the perfect swing arc.
Some of the stuff they've got, some of the new things that they've introduced the past couple months for the Unity runtime have been they take collision detection to a whole different level. They've actually got it to where you can almost build an entire scene with collision detection in Spine and literally just like drag and drop it straight into Unity and hit play.
That's pretty cool.
Where your animations will trigger your animations will trigger collision detection will fire event will actually trigger another animation on an opposing character. So let's pull that up real quick. So you've seen the basics of how to create the character, the animations. Again, just simple keyframe animations, nothing too crazy there. We'll wait for Visual Studio to come up here real quick. Yes, I'm still running 2013. Nobody make fun of me. Haven't upgraded yet.
So hard.
Oh, it's even worse at work. We're still running 2012 at work. 2012 professional.
Hey, that's like 2 years ahead of FedEx. 2010 Master Race over here.
All right, let's do this. So we're going to look at these two files. This is a hero decorator class and a hero behavior class. The decorator is basically where you go in and actually you instantiate all of the component structure that makes up the hero, including any behaviors, colliders, art assets, so on and so forth. Oh, by the way, if I don't remember if I mentioned this or not, this is all done with Wave Engine. It's a component-based engine that's it's done in .NET, cross-platform, yada yada yada, just like all the others these days. Everyone's cross-platform these days. So let's bounce over here to our resources real quick so you can actually take a look at what we brought over into the game itself. Nope. Nope. Oh, there's something right here in front of me. So that's it. Those three files. That is all we needed to bring over from Spine in order to make this work. The Atlas is just that. It's what tells you what on the sprite sheet is everything. There's our actual sprite sheet itself. Notice the power of 2. Their texture packer, I've actually been really happy with. There's a bunch of side notes on how to use third-party texture packers. I've never had any problems with this. He seems to do a fairly good job optimizing the layout. And again, we're using this just to optimize the component layout, not hundreds of other assets of the same thing. Though you can just as easily if you wanted to. I've been reading that seems to be the big thing these days is try to cram as many assets onto a single image as humanly possible, and that way you only have to call one load and that's it. You can if you want. It's not going to stop you as long as the Atlas is properly defined. It doesn't care. And then this JSON output, which this just contains all of the raw animation data itself. So just walking through the code really quick, and I mean really quick because there's really not a lot of it. These right here, this is the meat of it. This is how you get from Spine to Runtime. I've got a couple static resource strings that just point to the relative path of the skeleton data file and the skeleton animation. And that's all I have to do. The skeleton data file is going to point to the actual image itself. And as part of instantiating that skeletal data, it is going to load that image for me. I don't have to worry about actually loading the asset separately, loading the Atlas, tearing apart. The runtime handles all of that. And then from there, I actually have to give it a renderer component so that I can actually draw it on the screen. I think I've just got quads turned on for my debug mode just so I can see what it was doing. And then you just pass a layer and telling it, what kind of layers it is and additive layers and normal and whatnot. And that's it. That's how you create it. Now, how do you manipulate it? Once you get it created, we're going to look at the hero behavior. Within Wave Engine, the behavior is basically where you go and add your loop logic or your state logic. So as you can see, I have a ton of properties. I'm a property heavy kind of guy. I love them. I throw them all over the place, probably more than I should. We have part of our loop here, which is process animations. And this is where I just go in and do state evaluations. Where are you? What are you going to? What are you coming from? And then first time around, I go in and I set my mix durations between all my different animations. So I know that if I'm going to, from run to jump, what have I? So I've got like a 0.5, I think it's 0.05 seconds overlap between the two. And then these mix durations can be redefined on the fly. So if you ever need something that, it just doesn't seem right or doesn't line up right, you can always go back and tweak that. And this is it. This is literally how you go in and you tell Spine to play an animation. In this case, if it's not already playing and the current state's running, then set the skeletal animation's current animation to run, and then skeletal animation.play while setting the animation speed. Let's see here. If I go a little bit further down here, animation event setup. So this is called during initialization. This is just wiring up the on animation event handlers, or handler in this case. And this is looking for that, if the name of the event contains footstep, then I'm just calling up my sound manager to play the footstep sound. Do I still have to open? I do. So with the events, not only do you give it a name, you can actually also give it a value, int, float, or string, whichever works best for you. I was just looking for existence of events, so I didn't even bother defining anything. I just went straight off of the actual name of the event itself. Let's see here. So what this looks like when you run this, again, nobody laughed, nothing fancy. Oh, it came up over here. Oh no. There we go. Yep. So we got a panda with running, jumping. Notice there's smooth transitions between them. I don't know if anyone can hear that. It might have a little clicking sound, but you can hear the footsteps as he's running. And collision detection kicked in so that he died a very noble but anti-physics death, getting knocked backwards 3 feet just from running into a crate. So so that's just an example of, with Wave Engine, how easy it is. I know Unity is even easier than that. I believe they actually have a Unity plugin that can identify when you are using spine assets. And not being as familiar with Unity myself, I don't know exactly what it gets you, but I know it gets you a whole host of options of how it's set up within your levels or your scenes and how it interacts with one another. So that's it. That is spine in a nutshell, modular animation in a nutshell. So anyone have any questions? Or
how did you fire an event when you hit the crate? Like at what part did you fire the event to test the collision?
That's actually part of Wave Engine itself. During the initialization, it wires up to these two events, on collision and on separation. Mm-hmm. That's actually part of the game engine itself. Right. Every entity, So
do you have the event going the other way around? Like it's going from the collision to animating from falling backwards?
Yes.
Okay.
Yes. Once the here we go. I can show you. I can walk you through it real quick. On collision, I have a box collision counter that increments. I call it sound manager to play the thud sound, and that's for a category 1 collision, which is what I've assigned the physics collision category for the boxes. If it was category 2, I think that's just ground. So that just lets me know that he is touching ground. I use both of these counters just to kind of, when I'm going through my my state change evaluation, which is state. Let's see here. Can process state. Where is my? Oh, here we go. If is on box. So is on box is just a read-only property. It's just returning box count or collision count greater than 0. I can't shortcut today. There we go. There we go. So yeah, it just basically says if my collision count is greater than this, then I'm going to stop processing any input states, and then I'm going to set my current state to dying. Once the process animation portion of the loop hits and that dying kicks in, sorry, here, there, let's highlight that. So find it, process state animations, and yeah, there we go. All right. So if the dying animation isn't already playing and the hero's dying, then play the dying animation. So I need to come back and refactor this a lot. Obviously, you can tell this is just basically nothing but a straight line of if statements, but I'm going to eventually get around to one of these days. Actually, what I'm probably going to do is I'm probably going to go more heavy on events. And on collision, I'm probably going to raise an is dying event, which will then handle the transition to the animation. This was just a very quick, easy, down dirty way. Everyone's done it. Copy and paste. Don't judge me.
Yeah, in Unity, you probably have like using a canon to do it. So you have a state diagram.
This state diagram with the tree.
There's also animation events in Unity as well. Not to just dig into that myself.
Yeah, I bet you really use that diagram. Is that the one that Claire showed us a long time ago? The states.
Yeah,
That's like
actually-
a
Yeah, she was using
Is that a native plugin or is
Yeah,
that?
that's part of Unity. Yeah, Unity has a state machine editor for their animations.
Who was using that? Was it you? No, it wasn't you. She might have been Strat.
when
I don't use any state machines. Or
No?
use state machines for days.
I was just well, the
entire
one
game is nothing but state machines.
the one I was showing was behavior tree.
Maybe that's what I'm thinking.
So
of.
it's not really a state machine. It's,
Okay.
it's
Gotcha. Oh, yeah, maybe that's what I was saying. I remember seeing an editor with a whole bunch with a hierarchy.
Yeah, that was the
the
AI behavior tree.
Yeah.
Oh,
those are
okay,
behavior trees.
gotcha.
You actually could do something similar in Mecanum, but they just released state machine behaviors. It's like a separate.
And I think in behavior designers, you can fire off animations.
Yeah.
As well.
It's pretty easy to tie all that stuff in. Cool. Do you know what? Can you do motion capture with Spine?
Not with Spine.
Okay.
There is a project that's going on right now. I haven't been following it as close as I should be. It's some guys that are actually working with Wave Engine. There's obviously they've got the Connect library. Sure. Somebody's actually been working on trying to come up with the utility to do just that. Now, basically, what it amounts to is right now, so far as they've gotten it, or so far as I've seen they've gotten it, has to be like a bipedal model, and they create IK targets at each one of your major appendages, and then they don't actually create any animations. They create a freeform pose.
Right.
And then in the runtime, they take the connect input and they bind it to those IK mappings. So then you can actually move your model,
Right.
and then you can kind of generate, quote unquote, generate your keyframes from that. I think the last I saw they were working on is they were actually writing an adapter to output the JSON format so that Spine could understand it. But yeah, I think they were going for a basic mapping the connect to a pose,
Right.
and then again doing next pose, and then basically just mimicking the keyframes. Absolutely, it can be done. I don't know if anyone has actually gotten a finished product out.
Okay. Yeah, I just didn't know if you could import a BBH file into Spine.
Yeah, it looks
And get something.
Yeah.
No, but that's the guy that wrote it. He actually, I've talked with him several times. He actually gave me a lot of the stuff I used for the presentation, and he's totally open to feature requests. I mean, if it's something that he feels, and he hasn't come out with anything I think for about a month, so it might be about time for him to push and request for more. I might ping him about that on the side and say, hey, could you?
Right.
Or what would it take to, or something like that. So, excellent. Anyone have any other
Man, I wish
questions?
I'd picked up that thing. The Humble Bundle.
Did you not get it?
No, I didn't get
Oh,
it.
what? Yeah, I bought it too. Yeah.
Spriter.
Spriter.
It's
That's
Spider
what I
and
was
Sprite
thinking.
Lamp.
I haven't seen Sprite Lamp.
On the TV lighting.
Yeah, you basically have a sprite and you feed a bunch of height maps of that, grayscale height maps, and it calculates how all the shadows look like across it.
I have seen that. I just didn't know what it was called. Yeah. Okay. Sprite Lamp.
I don't have the use for it at all.
All right, check it out on the.
Wait a second. Hold on a second. Let me look at something real quick. It's funny you say that because here
Is it custom shaded?
I was wondering about this because I was looking the other day at some of these assets.
Node-based shader.
Yeah, this thing's got diffuse
built
maps
into the renderer. So you actually
and normals.
scenes from scratch.
You can feed that into
The modeling on that would
I
be
don't know,
super easy.
Spine throw a great skill.
Did all the lighting.
But something similar to that.
Yeah, I mean, it looks just like that.
I wonder if he's working on a new feature.
That'd be great.
Because he sent this model over specific, aside from the other ones that just come packaged with it. So I wonder if he inadvertently gave me a look at something he's about to roll out. That'd be awesome. I'd love that.
That'd be really cool with the mesh deformation and stuff.
Yeah.
You could actually animate the normal maps.
I mean, that would almost.
Really, really
I don't know
cool
if that
effects.
wouldn't. Fortunately, in Blender,
I won't go so far as to say that would negate the need for 2D or for 3D animation, but
It'd be damn
it would
cool.
definitely open up a new genre within 2D for sure.
I have to give it this much glossiness. I have to, and it's also combined.
Cool. Let me close all this stuff out real quick.
Yeah.
But dude, yeah, it's Blender has that. It's called the cycles renderer. So if you remember the other day when I was like, "You have V-Ray?" Oh, dude, I was like, "No way!" I was like, "No way, no." I was like, "You have it? That's crazy." But that is like one of the super professional, top level standalone renderers. But the cycles rendering engine in Blender is just kind of like that, but free. And I mean, you've seen those pictures on Blender, so it's like, if you know how to tap into the power of it,